After looking at all the derivation at different rate limiting steps, now we look at why the process called as a rate limiting. So for the first one, absorption rate limiting. So for absorption rate limiting, the rate constant of absorption is smaller than Ks and Kd. So rate constant of surface reaction and rate constant of desorption reaction. When the rate constant of absorption smaller than Ks and Kd, that's why we call it absorption rate limiting, because the absorption process very slow. Therefore, it will limit the reaction. So when absorption step very slow, surface reaction and desorption reaction more faster. Similar for surface reaction rate limiting. So in this case, rate constant for surface reaction is very small compared to rate constant of absorption and desorption, meaning that the surface reaction occur very slow compared to the absorption step and desorption step. And finally, for desorption rate limiting, the rate constant of desorption very small as compared to rate constant of absorption and surface reaction. So when Kd value is very small, the desorption process is very slow. Therefore, limit the overall reaction. Okay, now we look at the rate law for different reaction mechanisms that are irreversible and surface reaction limited. Okay, based on the video that I posted previously for irreversible surface reaction limited, I always stress on the denominator of the reaction equation. So this is a very helpful tips in order for you to determine how the reaction occur. So usually, certain problem you will have the mechanism, but certain problem you will be given with the overall rate law equation, and it's only stated that the reaction is surface reaction limited. Okay, tips. If the reaction either it is irreversible or reversible. If the reaction is reversible, look at the denominator and also nominator. So usually for reversible reaction, you will have a very complex reaction rate law equation. Okay. But for irreversible, nominator of the equation, very simple. But what we need to look at is at the denominator. So usually the case given is for irreversible surface reaction, but we don't know either it is single site, dual site mechanism, or irreversible mechanism. Okay. All right. For the first equation here, okay, so for this one, if the overall rate law equation given as this equation, okay, look at the denominator. Denominator is power of 1. So look at the denominator here. Denominator is power of 1. So if power of 1, then the species that attach to the active site only species A and species B. Look at the nominator. Only A appear at the nominator, meaning that you only have one reactant because the denominator is power of 1. So only one reactant and denominator determine either it is single site or dual site. Okay, so when the denominator is power of 1, it is single side mechanism. And then nominator only A appear, meaning that the reaction only involve one reactant and one product. So at the denominator should have a reactant and product that attach to the active site. Okay. And then, so during the surface reaction, this is the reaction occur at the surface reaction. And from here, you can determine how the desorption occurs. So you only have one adsorption step and one desorption step. Okay. And then nominator determine how many reactant involved in the reaction. So only one reactant, which is A. So from here, you can propose the mechanism of reaction. So the first one is, the first step is adsorption step. A plus S equal to, okay, saya tulis ini. A plus S, sorry, tulisan buruk. So, reversible reaction. So, remember, adsorption always reversible. A dot S. So, this is the adsorption step. And then, surface reaction step as given here. A dot S produce B dot S. And then, desorption, B dot S. B dot S. Allah, buruknya. Reversible reaction. B plus S. So you will have the complete mechanism of reaction. Okay, for single side surface reaction. Okay, then we look at the dual side mechanism. So the first one, okay, jangan tengok dulu equation. Look at the rate law equation given. Again, first look at the nominator. Nominator only A appear. So maksudnya only one reactant involved. But when we look at the denominator power of 2. Bila power of 2, automatically it is dual side mechanism. Okay, then lepas tengok power of denominator, look at the species involved. Only species A and species B, meaning that A, we know A as a reactant and B is the only product. Then, how the surface reaction occur when we have this rate law equation? Sebab dia dah, because we already know that A je appear at the nominator and A and B as at the denominator, so only B the product. Therefore, this is the mechanism at the surface here. So at the A dot S comes from adsorption step. Then during the surface reaction, the reaction require another vacant active site to produce the product B and leave another vacant active site, right? So automatically it is dual side mechanism, one reactant. Then next one, if the reaction rate law equation as this one, okay, look at the denominator K, PA, PB. So nominator referring to the how many reactant that we have in the reaction. So now we have two reactant, reactant A and reactant B. Look at the denominator power of 2. So dual side mechanism. And then look at the bracket in the denominator. We know that we have two reactant. So ada two reactant and both attached to the active site. Because ada KAPA, KBPB and KCPC. So only one product. Remember, at the denominator, all the species that attach to the active site must be appear at the denominator, which is product and reactant. So in this case, we have 2 reactants and 1 product, which is C. Therefore, how the surface reaction occur? So A dot S plus B dot S. So this species that attach to the active site comes from adsorption step. So how the adsorption step occur? So you will have 2 adsorption step. Adsorption step 1 is for the adsorption of A on the active site S, and adsorption step 2 for product B, B plus S to produce B dot S. So you will have 2 adsorption step. And then irreversible reaction to produce product C dot S plus vacant active site. Alright. So by looking at the overall rate law equation, we can determine how the surface reaction occur, and from the surface reaction, we can determine how the adsorption occur. And finally, for Illy-Rideal mechanism, how we guess that the reaction is Illy-Rideal mechanism? Okay, look at the nominator and denominator. Okay, nominator, we have PA, PB, bermaksud 2 reactant, which is A and B. We have 2 reactants. Then, look at the denominator. Denominator, power of 1, meaning that it is not dual site mechanism. But what are the species that attach to the active site? We know that we have 2 reactants, but only A, reactant A, appear at the denominator. So only A that attached to the active site. Only A absorb on the active site. And C as a product at the active site. So when we know that there are 2 reactants, but only A appear at the denominator, automatically species B only involved in surface reaction as a gas and via Illy-Rideal mechanism. Okay, so we need to look at the overall rate reaction where it is appear. And then KC, so of course C as a product, so dia akan appear and attach on the active site. So this is how we determine the mechanism of reaction when we have the overall rate law equation.